My name is Ruben Ferraz. I'm Field Product Marketing Manager in Europe for Cognex Deep Learning products. Today, I'm here to demonstrate how easy, intuitive, fast, and powerful inside ViDi with Cognex Deep Learning can be. Before we start the demonstration, it is important to explain why Cognex is investing so much in deep learning and why we have chosen these parts for this specific demonstration. I will simulate what might happen in a real production line where parts are susceptible to change in their shape, in luminance, in contrast, unwanted reflections, and so on. I will now switch on the live video mode of my camera to show how our demo parts look like. I have 4 good samples and 4 bad samples. By switching on the live video mode, I can adjust my part in front of my camera for the given field of view. Now I will switch off the live video mode and adjust the image because my part looks a little bit dark. I will double click the A0 cell and I will switch on HDR+. In this way, with HDR+, my image will compensate the contrast in the complete image and will enhance its contrast and improve the image quality. As you can see now, it's much better and I can see much better the structure of my part. Here in the background I have a carbon fiber card. I have 4 different samples. I will switch on again my live video mode. As you can see, this is my part number 1. This is my good part number 2. This is my good part number 3. And my good part number 4. If I put them side by side, you can see that the carbon fiber structure is changing from among all those parts. The reflections are in different places. The structure is different. And that is not a problem for the deep learning technology. If we train correctly those parts, if we are consistent in labeling these parts, the deep learning technology will create a neural network which will be able to detect any defect or any anomaly which appears in this card. And if I flip this card, in the back side I have the defects. In this case here, this is one defect. If I flip this one, this is another defect in a different position. I will flip the card number 2, I have another defect. And if I flip card number 4, also a different defect. I will now switch off the live video. I will remove my parts and I will start collecting the images. I will now switch on the live video mode in order to acquire some images. I switch on. I could also press the trigger button, but in order for you to see that I am moving the parts in front of the camera, I will use the live video mode. Now I switch on the record button. If I switch off the live video mode, I acquire my first image here. I switch on the live video mode, you see that I will change the part. Now I will train the part number 2. Now I will have part number 3. I am collecting one image of every single good part. Now part number 4. Now I can rename all of them in a batch. I click in one of the images, I select all of them by pressing Ctrl A. I right click, click in rename frames. I will call them good underline as a prepend. You see that I have my good underline in front of all of this. For this one I could do that manually, renaming one by one because I don't have many images. But imagine if you have hundreds, thousands of images in your film strip. This is a great feature that you can rename in a batch. Now I will switch on my live video mode and I will collect one bad part just for supporting me when I am setting the correct threshold for the system. Now I have one bad part here. I will switch off my live video and I will rename this one as bad. So I have 4 good parts and 1 bad part. Now let me go back to my first part. I double click in the film strip and I will start creating my PadMax tool. I will open here my Vision Tools, Pattern Match, and I will drag and drop Train Pad Max Redline. As you do with the Inside Explorer, you just drag and drop the tool, double click the pattern region, select the feature that you are looking for. In this case, Cognex white and the background in black gives me a perfect feature for traditional vision system. I press OK. Now instead of drag and drop, I can also type find Pad Max Redline. If I click in find region, you see that this is the region that I'm looking for. I want to make this in the entire region. I press this maximize region. Now I have the entire region. The pattern, I will double click and point to the A2 cell. Now I have the A2 cell here pointed to my pattern. You can already see that I can find my Cognex logo with this green cross. And I will switch on the result graphic only so that we can always see this green cross when we find Cognex logo. I will also here put minus 180 degrees for tolerance and plus 180 degrees. So if I want to put my part upside down, I can also find and do the inspection. I press OK. I have corrected the image with HDR+. I have trained the pattern using Train Pad Max Redline, and I also find my pattern with Find Pad Max Redline. I have also acquired my image. I'm ready to go to deep learning. I'm ready to go to ViDi Detect. So now I will open my ViDi tools. I will drag and drop ViDi Detect. The window will pop up. I will select the region that I want to inspect. This is the region that I want to find my defects. I will also put an external fixture, so I will double click the external fixture and I will point that to the cell A4. This is Find Pad Max Redline. Now it is fixtured, and I will also drag and drop the show outside because I will use this cell A9 later on in my HMI in order to hide and display the graphics from ViDi. Now I am able to open the ViDi editor. I have my 5 images here. I can press Ctrl A and drag and drop all of them in the right pane. You see that the fixture is working well. The system is already automatically fixturing all the images for me. Here I have just 5 images. I could label them one by one, but if you have hundreds of images, you can also tag them as I did before with good. I will put here good, and now I have 4 images. I will click in action for views, label views, and click OK for all of them. I can do the same for the bad one. Just reminding that I don't need the bad one for the training. I need the bad one just for setting correctly my threshold. This is my bad image, and I will label this one as a bad. Now I will display all the images. I can show that I have labeled 4 images good and 1 image bad. I will not train the bad image. I can also show here that my parameters, I have some parameters for deep learning. I could, for example, change the feature size, but it's not necessary in this case because you see that the feature size, it's about the size of the defect that I am looking for. So I should be good to go. I will press the brain icon, press yes, and here instead of going with the default set for 50%, as I have just 4 images, I will train 100% of the image, so I will train 4 images. I will create my neural network with 4 images, and then I will do the inspection. I press OK. Now, as you can see, the system will analyze and then create the neural net. You can follow the progress here. This process takes about 3-4 minutes. Meanwhile, we can jump to the HMI. I can, for example, delete these 2 things because I don't want to use that. I will move the region where we can see the part to the top just because I want that. The goal here is to show that it's flexible. We can change the size, the shape, the location. I will move down these buttons here. I will put trigger once here, so we have some time to create that. I can show you, for example, that if I have 3 icons like this, I can make them in the same line just by clicking this icon here, and I can move all of them together. So this is how my HMI will look like. Now we will go back to the spreadsheet, and I have this cell A9. I will right click and I can publish. As soon as I publish, it goes here to show. I will leave this tag as a show, and I can also create a different one. For example, I can type and get all time. This function is displaying in the spreadsheet the total processing time of the spreadsheet, including image acquisition. The time is here. And I can also use another function of the spreadsheet. This is just an example. Format string. The format string, I can type the leading text processing time and the trailing text ms milliseconds. I will add this one here, the A1, and this is the text that you will see later on. Processing time 0 milliseconds. I press OK, so I have this text here. I can right click and click publish. I could also create a web page from selected cells, or I can just click on the cell and come here to this field and I put processing. This is the tag that I'm putting here. You see that I have a new tag here, processing. Now I go back to my HMI, I click in tag, and then here if I type processing, this is the name of my tag. I open here tasks, and then I have processing. I will just drag and drop this one here, and I can also have the other one, which is show. I put it here. So the show, this one I will move here, and this, I don't need this label processing because everything is here. I will just enlarge a little bit. So let's make this font a little bit bigger. We can see the processing time here. The show is here. I have my trigger, cam, pause and online. And in this field here, I will drag and drop a picture of the camera and I will place it here so that my application looks nicer. I have here the height 507, so in order to leave this with the same height, I go down here and I will change also to 507 so they have the same height. So better look and feel. My HMI is ready. Of course, I can do some more improvements here, but the goal is to show that it's very flexible and very easy to set. Now, before I go online, I will go back to my spreadsheet. I will right click on the ViDi detect and I will click in insert getters. This function is now collecting all the information that the ViDi editor has generated and pulling all this information to the spreadsheet. You have to do that just once. Once you have all the information in the spreadsheet, you are good to go. Now you see that I found here all the getters. I can now open my ViDi detect, open the ViDi editor. I go back to my ViDi detect tool because the training is ready. So you see that the training has finished. I will open my database overview and you can see that ViDi has separated very well what's bad and what's good. I have just to increase a little bit the threshold for the lower threshold here because you see that in the right side the defect shows much bigger. Here I can give a little bit more tolerance and I tell to the system that this is the size of defect that I'm looking for. If any of the parts fall in this part here, still good. If it goes beyond this lower threshold, it's going to be considered a bad part. You see here that I have 5 images, I label 5 images, and I trained 4 of them. The one bad part was not trained, and here it's clear in this confusion matrix. I will minimize here. You see that I don't find the defect for the good ones and I find for the bad one. But so far I have created the neural net. Now let's see how the system is I will now click in the spreadsheet, and before I go online I have to associate my past cell to the film strip. I do that by clicking the past cell, the G6, I right click on that, and I will set that as a watch cell. I press OK. Now I am good to go online. I will press the online button. The system will load until it goes online and will start doing the inspection for me. Now the camera is already triggering. It is acquiring images. You see that I have a defective part. It finds the defect. I will switch on here the result graphic so that we can see the defect. If I zoom in, it's clear that it can find really well the defect. I will zoom out. So this is the not good number 3. I will pause the system. I can also trigger one by one. So now I will put my finger as well. You see that I can find a big defect. I can also create some other defects, like this one here. I have a very small piece of paper and the ViDi system finds the defect really well. So now before going to the other images, I will switch to the web HMI. So I will click in this home button and I click Open HMI. It will load my default browser. I have it here. I just have to refresh. So I have my browser, and if I go online again, the system is doing one inspection after the other. If I move my defect, you see that it still finds this small piece of paper. So if I take out this piece of paper, I still can find the defect. If I turn it upside down, I still can find the defect. Now if I have my other defects, this is defect number 2. You see that it finds the defect here. Defect number 1. Defect number 4. And if I flip my cards, I have the good parts again. So, okay, number 4. If I take this out, so it doesn't find any defect in the OK number 1 either. No defect in OK number 2. No defect in OK number 3. Now let's see what happens if I put this card here. I will change the graphics for input and result graphics. You see that this is the region that I am inspect, and of course the system finds really well the defect at the edge of the card because it looks like a defect for the system. If I twist the card a little bit, you see that I'm starting to find defects in the card because the orientation of the features are not the same anymore. If I put something like this, the orientation is completely different. It finds this card as a complete defect because it doesn't have the same orientation. Now I will put back as I had before. You see that it finds just the edges as a defect because this center here, this part here, looks pretty much like the ones that we have trained, even though it's not exactly the same. So this really shows the power of ViDi. Now let me put back one good part. I will put back this good part here. See, we have no defects anymore. I will pause my system. You see that also the processing time, it's taking like less than 300 milliseconds to do this complex inspection. In about 20 minutes, I have showed you how simple, easy and fast it is to set one application completely from the scratch. Thank you very much.